Okay, folks, continuing on with our electrical part, we are going to start talking about electrical theory and then we'll get into electricity and also magnetism. It's important that you understand because we use a lot of magnetism and electronics in cars. So let's go ahead and get started. I'm going to go ahead and, like always, I'm going to push up a screen for you to look at and we'll get going on this so you can understand. So, uh, when it comes to induction, there is a magnetic field that actually is generated when a electrical current goes through a wire, and we can actually use that to help apply certain components. And it's really important that you understand how that works. If I turn the clutch on, that is through magnetism. We're actually using that for, if I turn on a solenoid, that's actually magnetism. So we'll continue on with this. So there's electrical theory, as far as it goes to Watt's law. A lot of times what you get is you get components that are measured in watts, not so much in amps, and stuff like that. So Watt's law kind of governs the relationship between power, voltage, and current. Power is the measurement of the rate at which the work is done or the rate of which the heat is generated. Voltage is pressure, like we've learned before, or force that causes the current to actually flow, so that the little guys working inside the wire is like what I said before. A unit of measure for power is the watts. So that's what we're talking about. So we know how we can actually figure out a part of a circuit when it comes to Ohm's law. Now this is getting into Watt's law. So how to figure out Watt's law of power. The power, kind of circle, which we've seen in Ohm's law. If the cooling fan is rated at 150 watts and the voltage is 12 volts, Watt's law can be used to calculate the current flow. Cover the unknown, okay, like we've done before with the Ohm's law. And if we cover that, then you can do the math. So we've done this before, and I wanted to point out, we see this, we got so many watts a bulb is, so many watts a component is rated. How do I know what current is and voltage is, and how do I actually figure that out? So basically, if you're figuring out Watt's law, it's very similar to Ohm's law, but we're using it for kind of, figuring out that actual power, okay, how much power is being produced. So if you look at it, it's, P, which is the power, which is Watt's law. And then we use like we've done before, we've got let's break it down to something it might be a little more understandable to you. I remember I is for what? Intensity. What is intensity? Okay. And then E is for the voltage. Okay. And then we have the actual ohms. Okay. So we're going to take the actual amps, intensity of amps times the voltage. Ohms, I was getting off base there a little bit, but we're actually taking that power by volts, and then we're actually taking them multiplied by amps. Okay, so amps being your little guys running around, E being your actual voltage that you have. So it gets a little confusing sometimes, but you can get it after you kind of figure it out. So again, you're doing the math, power by volts, and then your amps, what you have in amps wise. So when it comes to magnetism, when we talk about magnetism, we're talking about like I said before, when a current goes through a wire, it produces an actual magnetic field, and we can manipulate that by kind of running it around a actual iron core to actually multiply it even more. As we turn the voltage on to that actual uh, component, then we can actually create a magnetic field. You'll see the windings that they have on here. So we have these windings, and that helps create a bigger magnetic field. You can actually create uh, a voltage off of a magnetic field with just a magnet and a wire, and it's kind of cool to do sometimes. We get to do that, pretty much in your electrical class and all. So some devices that rely upon principles of magnetism are, of course, any electromagnet. Okay, the compressor clutch, like I've been saying for a while. When we talk about solenoids, I said that too. And in electrical motors, okay, you think about it. How does that work? How does it spin that blower motor? How does it spin the actual uh, electric motors on your wheels on electric cars? And then, of course, generators. We use that to multiply, which is, we call them alternators, or actually generators, because they generate, voltage and current. So you're talking about these different devices actually use magnetism. One thing I got onto a little bit before in one of the other videos was actually about a clamping diode. This helps keep it from doing any kind of damage to the sensitive computer components. They can have the clamping diode inside a relay. They can have it on a solenoid, and of course, we see it a lot on a compressor clutch. So one of the things I did want to start getting into a little bit was on the multimeters and using them. And also I wanted to really get into a little bit about, how I can use a multimeter and how I can use an oscilloscope. I didn't really put up any slides on that, but I will be putting on those soon. But with an oscilloscope, you can see a better picture than you can with a multimeter. But let's go over this a little bit. So there's two types of meters out there. You don't see too many of the analog meters out there. They've pretty much gone away. It really got down to looking at a meter, and you had to kind of guesstimate on what the voltage was. It was a sweeping type meter, and it was a little bit difficult to read. Whereas a digital meter is a lot more precise. You might say it depends on the refresh rate and what kind of meter you bought, because the cheaper the meter you buy, the less accurate it can be. I'm not saying all of them are wrong, but so like I said before, an analog meter is more of a sweep meter that has a scale on it. You'll have it where it kind of scrolls around. Oh, not scrolls, but it actually has a little actually it'll be almost looking like a digital meter, but it'll be a little bit bigger, and it actually has a sweep meter on it with a scale to it. These actually had a very low impedance in it, and that was the problem why we kind of went over to the digital ones. Plus, it was, you could get a number versus an actual, okay, I got to guesstimate at the scale. So that's one of the things that really was important. You didn't want to damage your electrical circuit. Not saying all of them were. There were some of them that had a pretty high impedance. And when I mean impedance, folks, I'm talking about how I don't want to put the meter in the circuit. I want to get a measurement kind of outside the circuit. If I have a higher impedance, I've isolated myself from the circuit, and it doesn't add into the circuit design. So this is why we want to have a high impedance meter. And then some of the well, when it comes to magnetism like that, we can have some side effects of induction. When the current flow through the coil of the wire is suddenly can stop, which, and we turn it on, we turn it off, we turn it on, we turn it on. And that's where we can actually induce a voltage that can actually run back to the computer or a sensitive component like electronic, and it can actually damage it. So that's why we use an actual clamping diode. We want to make sure it doesn't go back to the computer. We can actually isolate it on out. So we want to make sure we don't damage anything. All right. So I think I'm going to stop here. It's a little, if you have any questions, please feel free to reach out to me. I'm going to do some more, videos fairly soon, but I wanted to kind of get us into the electrical part of air conditioning at this point, and kind of get your minds thinking about things and how to diagnose a little bit better. And I'm not saying they're not diagnosed right. I'm just saying, how can I help you diagnose an electrical problem in AC? Because the basic principles of AC is pretty simple. I mean, how the refrigerant flows through the system, how we actually take the pressures and we know what's going on inside. We can check for a component that's not functioning properly. So there's all these things we could do with the basic function. And now that we're more and more electronic on the AC systems, we need to know a little bit more about how the AC system works, on the electrical side of the AC system works. All right. So if you have any questions, please feel free to reach out to me. You've got my cell phone. You've got my my actual email address, and if you want, you can always comment down below here, because this is a YouTube video. I'm not looking so much for a the likes and stuff like that, but if you do like it, please feel free. And if you have any ideas of how I can do a little bit better at this, please reach out to me. I appreciate it. Okay, that's it for now. We'll talk to you soon. Bye for now.